The purpose of this video is to briefly explain water-cement ratio and go through a process of determining the best ratio to use when mixing concrete. We'll start the video by giving a brief description of water-cement ratio. Water-cement ratio is the ratio of weight of water to the weight of cement used in mixing concrete. Higher ratio leads to an easier to manipulate concrete, but lacks the strength of those from the lower ratio. For this exercise we use 4 large cups, 4 16-ounce cups, scale, cement, water, sticks for stirring, and scrap wood for our forms. We begin the exercise by zeroing out our scale and weighing the cups, since the reading with the cement or water includes the weight of the cup. We document that the larger cup weighs 0.65 ounces and the smaller cup weighs 0.34 ounces. With the 0.65 in mind, we add 8.65 ounces of cement to each of the 4 large cups. A popsicle stick enables us to precisely add or subtract cement to each one of the 4 large cups to get the weight to 8.65 ounces. Next, we determine the amount of water needed for the given ratios and added it to the appropriate small cup. We added the water from each ratio to a cup of cement and begin mixing. Following mixing, we added a fairly even amount of each ratio to each set of our formwork. Here you can see the difference in the mixtures. The 0.3 is very chunky, as you can tell, and the 0.6 is very runny. 0.5 is definitely not as runny as the 0.6, but it still feels too easy to manipulate. The 0.4 seems to be the best mixture because it's moldable, but at the same time holds its shape and form. At 12:41 p.m. we set one of the mixtures outside and left the other mixture inside. The average temperature outside was 51.8 degrees Fahrenheit. The average temperature inside was 68 degrees Fahrenheit. Every 2 hours we checked each set of mixtures to monitor the set time differences. With a small stick and a slight amount of pressure, we poke each mixture to test. Each mixture has now been sitting for 8 hours. The mixture from inside doesn't show any deformation or coats. But as you can see with the mixture from outside, it still shows deformation, only slightly on the 0.5, but you can actually see the moisture in it on 0.6. After 10 hours you can see that the mixture that was left inside has set fairly well. When compared to the mixture left outside, you can really tell the difference in setting times.